Okay, well, again, $1,000 plus 0.06 times $1,000 is the same as 1 plus 0.06 times $1,000. Really, I've just factored out $1,000 from these two, but just to verify it, we can go, we can multiply this out. 1 times 1,000 is 1,000, 0.06 times 1,000 is 0.06 times 1,000, so this is the same as this. You have to believe it.
I believe it.
Make sure you convince yourself. What's 1 plus 0.06?
1.06.
Okay, so I didn't have to do all these steps. I just had to multiply every number by 1.06, right? Okay? Well, there's more to it. Okay, so using that idea. Wait a minute, I didn't hear it. Probably a good thing.
You went, well, that's not what there is to it. I was like, dang it.
More to it.
Okay, somebody enlighten me later. Okay, now, so I know who to blame. Okay.
Just rewatch
I always
this.
know.
Just rewatch the video, it'll be in there.
That's over
No
here.
question. Okay, so I could have done this.
You'll need to break that out for that part, for managerial.
Everybody agree, right?
Mm-hmm.
Okay. Well, in this year now, I'm not going to write out what the number is. A good reason for it. I could write it out. I mean, that's easy, right?
Yeah.
Yeah, I don't know. Magnets. Okay. And not even any blood. I stabbed myself on a paper clip handling somebody's test the other day.
Oh my God.
Well,
Did you fail them?
I ripped off their
I
solutions
wouldn't.
from the original, and that caused the paper clip to open up at the back, and then I grabbed the original in the wrong place.
Ow.
It's just like getting your finger pricked for blood, there's little blood. So,
Did you get blood on their test?
whoever that is, I forget whose test it was, but now they have a DNA sample. Okay, anyhow, okay, so here we go. Okay, you understand this, right?
Uh-huh.
What did I do with this number to get the next year? I multiply it by 1.06, right?
Mhm.
So I multiply, 1.06 times 1.06 times $1,000. Right? Okay, well, what would I have in the next year?
1.06 times
Times
1.06
1.06
times
times
parenthesis 1.06
You have
times parenthesis 1.06 times 1,000 close parenthesis.
Close all the parentheses.
Close them all. One more.
Well, I did this to save myself the trouble of writing out the whole blame calculation. And look at what's happening.
So can't you just square it?
Yeah.
106
Yeah.
square it?
Exactly. So my question was, and you've anticipated it, and I'm not surprised, that was very good, okay? If I write this as okay,
1.06 squared.
this is getting a pain. So instead of putting up with the pain, like the pain I got from scraping my knuckles on this thing and stabbing my finger. But, in my profession, I expect pain. Now, okay, so what we have here is
I'm lost now.
1.06 squared times 1,000. And this is, I'm glad you have a sense of humor.
A strange one, but one all the
Strange one.
Now, the only problem is I got two dollar signs in this, so I gotta get rid of that, but is there a pattern?
Yes.
What am I gonna have the next time?
1.06 to the fourth.
Okay?
Oh, goodness.
You just keep adding a 1.06.
So, we have an easy pattern. After T years, how much do I have?
After T years, you have T times, no.
T,
106
1.06 to the power of T times 1,000.
Yeah,
Yeah.
because the number of year is my power here, right?
Yeah.
Okay? So I have 1.06 to the t times $1,000. What kind of a function is this?
That is
Exponential.
An exponential function. What's the base?
I wasn't even paying attention to the
base 106.
1.06.
Yeah.
What's the exponent?
T.
T.
T. Okay, so this is an exponential function.
It's been a long time. A long, long time.
Base 106.
What?
Base 1.06, right? So, principal is a function of t. Don't make me laugh. $1,000 times 1.06 to the t, right?
P to the T equals 1,000 times 106 to the T.
So, what's p of 2?
P of T.
Would be 1.06 to the power of 2.
Yeah,
Like
1,000 times 1.06 to the power of 2. What did we get for the year 2?
1,060.
1.06 to the power 2 times 1,000, which is just like 1,000 times 1.06 to the 2.
Yeah,
Yeah,
something like that.
commutative law of multiplication, right?
Yeah.
Very easy. Okay, so for any t, this is going to work. Okay? Now, this only works for whole number years, but it's still a perfectly good function. Its domain is the counting numbers.
Oh, principal.
Actually, the whole numbers, 0, 1, 2, 3, 4, 5, right? It's not a continuous function. It's only applicable at whole number years. Okay? Now, we could make it into a continuous, well, it's not actually going to be continuous, but we could define it for everything in between using a greatest integer function and stuff, and we might do that, but that's not important. You understand what's going to happen. So now, if I want to know how many years it's going to take for this $1,000 to grow into $100 million or $10 million, I could set
So you would do
this
what?
equal to $10 million and solve it, right? It's not going to take 350 years this time because my interest rate is higher.
Mine
Okay.
too.
You said what to $10 million?
Well, if I set this equal to $10 million, now we know how to solve it, right?
Oh, yeah.
So let's go ahead and do it. I mean, it's very easy now that we know how to convert between exponential and logarithmic form.
$10 million.
Last time, we solved the equation 1.04 to the t. 100 times 1.04 to the t equals 10 million. I didn't tell you where it came from because it was right at the end of class, and I just wanted to show you, here's a calculation that could be relevant. Although, you know, $10 million from small investments, you know, investments that are small compared to $10 million is, you know, something you're not going to live to see, right? You're not going to live to see this one either, but it's a lot shorter than the other one. So let's figure it out.
20%.